Hello everyone, welcome to Audit Course Week 6 Part B. Today's topic is NPN BJT Output Characteristics for Common Base Configuration. So we need to set the circuit up for the output characteristics where base terminal is grounded, which is the common between the input and the output side. So the input side consists of the the voltage source VEE and resistor RE of 1 kilo ohm, and the output side consists of the resistor RC of 1 kilo ohm and voltage source VCC. So we need to select NPN BJT from the component library. Also need to select from the library voltage sources VEE and VCC. So name them accordingly, capital VCC and capital VEE. Then right click on the VEE source. So click on advanced, none will be selected and click on OK. Similar thing do for VCC. So right click on the VCC source, click on advanced, none will be selected, click on OK. So this step ensures that the VEE and VCC can be varied, the voltage sources can be varied. Now we have an option to define our own NPN parameters. So in order to do that, we need to, let's say we want to define our own beta value, that is 100. So right click on the NPN transistor, rename it as NPN1. Then from the rightmost corner of LT Spice, locate .op, click on it, select Spice directive, and type the following coordinate, that is dot model NPN1 NPN BF equal to 100. So NPN1 means it's the user defined name. NPN is the reserve keyword indicating that it's a NPN BJT, and BF equal to 100 means beta is equal to 100. So when you click on OK, this statement will appear on the schematic. Or even better option is to right click on the NPN transistor. Basically this is NPN, sorry it's written as PNP. Right click on the NPN transistor and click on the the new transistor, scroll down and select BC547. Actually it's a mistake over here, it's written as BC557, but it's really BC547B. So right click on this transistor and from the pick new transistor you select, scroll down and select BC547B. Okay, so once you do that, we need to label these three terminals. So to label that, right click on the wire, click on the label net, and you will get an option to enter the this thing. So enter C, E and B at the respective positions and click on OK. So for the output characteristics, we need to label the base, collector and emitter terminals as B, C, capital C and capital E. So to add the label, right click on the wire, click on the label net, enter the label and click on OK. Okay, so your screen will look something like this. You will have this labels E, capital B and C over here. Now once your circuit schematic is ready, go to simulate, click on run. Next select DC sweep. So you'll get an option to enter the name of the first sweep, enter the name of the first source to sweep. So enter it as VCC. Type of sweep will be linear. Start value 0, stop value 10, increment will be 0.1. And I also enter the name of the second source to sweep as VEE. Type of sweep will be linear. Start value 0, stop value 2, increment will be 0.5. This step means that we need to vary the value of this step means that we need to vary the value of VCC from 0 to 10 in the steps of 0.1 and vary the value of VE from 0 to 2 in the steps of 0.5. Now click on OK. So this line dot DC VCC 0, 10, 0.1 and VE 0 to 0.5 will appear on the schematic. Also at the same time, a new window, blank window will open up with x-axis going from 0 to 10 volts. So what we need to do is we need to plot the output characteristics. Here there is a mistake. Output characteristics. So output characteristics is IC versus VCB. So after a blank window will appear with x-axis going from 0 to 10 volts. So we need to right click anywhere inside the blank window waveform. Click on add trace. Select IC of transistor Q1 and click on OK. So you will observe a plot of IC versus VCC, which is looking something like this. But this is not the plot we desired. We desired to plot IC versus VCB. So what we need to do is right click on the x-axis of the plot. Right now the quantity to be plotted will be VCC. Change it to V of C. You remember we have labeled the collector terminal as a C, capital C. So we need to change this VCC from VCC to V of capital C. So why? Because the base terminal is grounded. VCB will be VC minus VB, where VB is 0. Hence, if you wish to plot VCB, that is same as VC only. So hence we need to change this x-axis from VCC to V of C. Click on OK. So your desired plot of IC versus VCB will appear on the screen. So your IC will be in milliamperes, VCB will be in volts. As you can see, this plot is going towards negative. I hope that this will not touch the actually the zero axis. It will stay on the it will stay in the midair. So basically, it will not coincide over here. To ideally it should, but practically it will not in LT spice. So basically, you can take the any of the curves, that is the upper one, the middle one, and the lower one. Any of the curves you can take and note down these readings. So what does this mean is it is taken at various value of VBB, that is 0, 0.5, 1, 1.5 and 2 volts. Actually one line will be on the x-axis also. So here the for negative values of VCB also the transistor is working, and at what particular value the IC current is 0. So we need to note down the value of IC for different values of VCB. So these are the readings: minus 500, minus 300 to plus 8 volts. So correspondingly note down the value of IC. So this is my desired plot of IC versus VCB, that is the output characteristics for NPN BJT in common base configuration. So I guess we have completed our objective of plotting the NPN BJT output characteristics for common base configuration. Next time we'll see some other configuration for a BJT transistor. Until then, have a good day and thank you.